Good morning, class 11th. Today we are going to talk about the plotting of quadratic function. People suggest that it is not very important, but I think it is very important because this is going to help you in understanding the conic section later on. So I have written a question here. Y is equal to x square plus x minus 6 is the function which is given. Now we told you that quadratic function will be of the shape either this or this, depending upon if a is greater than 0, that means if a is positive, the parabola will be opening upward, and if a is negative, then parabola will be opening downward. Here I have got y is equal to x square plus x minus 6. A is the coefficient of x square, which is 1. B is the coefficient of x, which is 1. And C is minus 6. So I can see that A is positive, so obviously parabola is going to be opening upward. Next thing is vertex. We have to find what is the vertex of the parabola. This is called the vertex, where it changes from minimum to maximum. It comes to minimum value and then start changing its position going up, or it goes till maximum and then start changing to minimum side. It increases to an extent where it reaches maximum and then start decreasing. Here it is decreasing to a point and comes to a point which is the lowest and then it start increasing. This point is called the vertex of the parabola. It is called the vertex of the parabola. And we told you that the vertex, the coordinates are given by the formula minus b upon 2a and minus d upon 4a. You are very well aware what is b, a and d. D is discriminant. D is discriminant, which I have calculated here, b square minus 4ac. B is 1. So b square is 1 square minus 4 into a is 1 and c is minus 6. So 4 minus 4 into minus 6 will become 24. 24 plus 1 is 25. So value of discriminant is 25. So when we look at the vertex, it is minus b upon 2a minus d upon 4a, that is minus 1 upon 2 and 25 upon 4. I have already drawn here axes. This is x-axis, this is y-axis, this is origin, this is y-axis here. The horizontal axis, x-axis, the vertical axis, y-axis. And I have written the point 1, 2 this side, minus 1, minus 2, minus 3 this side. And I have drawn the line of symmetry. Parabola, what is the line of symmetry? If I draw a vertical line through the vertex, I get a line of symmetry. And what is line of symmetry? All the points on the left and right of this line of symmetry will be symmetrical. That is what line of symmetry is. This parabola is exactly symmetrical about this line. If I fold this parabola along this line, then this portion will cover this portion completely. Or if I draw a line here through the vertex, then this will be also, both sides are symmetrical. So this is called line of symmetry, and line of symmetry is given by this. This is the vertex, x coordinate of the vertex. So x is equal to minus b upon 2a, which is here coming minus 1 upon 2, according to whatever values we have been given. X is equal to minus b upon 2a, so I have got value minus 1 upon 2. That is why I have drawn a line. This is minus 1, this is 0, between 0 and 1 I have drawn a vertical line which will represent x is equal to minus 1 upon 2. X is equal to minus 1 upon 2 means line parallel to y-axis at a distance x is equal to minus 1 upon 2. Now let us look what is the vertex. Vertex is minus 1 upon 2 and 25 upon 4. On this line, the value of x everywhere will be minus 1 upon 2. And it is 25 upon 4. 25 upon 4 means 6.25. So 6a is here, minus 6, this is minus 25 upon 4. So minus 6.24 somewhere here approximately will come. So this is your vertex. This point is your vertex. Now how do we get the roots? Where y is 0, where y is 0 you get the vertex. So x square plus x minus 6 is equal to y. We have substituted x square plus x minus 6 is equal to 0, and we calculated, we factorized it because it could factorize easily with trinomials, and I got the value of x plus 3 x minus 2 is equal to 0. X plus 3 is equal to 0 means x is equal to minus 3. X minus 2 is equal to 0 means x is equal to 2. So I have got two roots. As you know that there will be two roots, because as it is the value of discriminant is positive, so roots are going to be real and distinct. You know that by the nature of roots, because discriminant is coming 25, which is positive, and so the roots are going to be real and distinct. Distinct means there will be two different roots. So I get minus 3 0 and 2 0. Minus 3 0 is this point and 2 0 is this point. Now you have got 3 points. It will come something like this. Whenever we plot a parabola in this, what we do is we calculate certain points. You could calculate points here also. There is no problem corresponding to minus 1, minus 2, minus 3, minus 4, minus 5 and minus 6, and you will get the correct shape. You can get the other shape, correct shape. This is correct shape in a way, but somebody will say you go directly from here, then you go directly. No, it is of the form, it is an approximate figure which gives you the roots of the function, which is minus 3 0 and 2 0, and it gives you the vertex, which is minus 1 upon 2 and minus 6.25. You can plot more points and it will obviously go up here, it will go up here. So this is your required parabola, which is represented by y is equal to x square plus x minus 6. Two things you must remember. You must calculate, first of all you must decide whether it is going, A is positive or A is negative. If A is positive, it is going to open upward like we have shown here, because A is positive. Then you calculate the vertex of the parabola. The vertex of the parabola is calculated by the coordinate minus b upon 2a and comma minus d upon 4a. D is discriminant, which we have already calculated, and from that we got the values as minus 1 upon 2 and minus 25 upon 4 in this particular case. So I plotted here minus 1 upon 2 and minus 6.25. Now I said this is the line of symmetry. See the distance here and see the distance. These 2 points are exactly symmetrical. The distance is 2.5 this side and 2.5 this side. So these 2 points, minus 3, 0 and 2, 0 are symmetrical about this line, x is equal to minus 1 upon 2. Then we calculated the discriminant to get these values. Then I factorized the whole quadratic function, and I got the value of x and y. Though you can take certain more values, like you can make a table here. Your function is y is equal to x square plus x minus 6 minus 6. You can give different values to x, and corresponding values of y should be calculated as usually we do. For example, if x is minus 1, if x is minus 1, suppose, what will be the value of y? Minus 1 whole square is 1, minus 1 will cancel, so it will be minus 6, minus 1 minus 6. If I take minus 2, suppose x is equal to minus 2, what will be the value? minus 2 whole square is 4, minus 2 minus 6, it will be 4 minus 8 will be minus 4. So you can plot these points also, minus 1, minus 6, minus 1, minus 6 somewhere here, and that will give you the exact shape, minus 2, minus 4 here, so that you get in between the correct shape. You can get the correct shape in between. So you can plot many points and in between here, so that somebody says this is not the shape. Yes, exactly, the points will come and you will get the correct shape. The next question about plotting of the quadratic equation is the y is equal to x square minus 5x plus 6, and it has to be plotted between the values x to be greater than equal to 0 and less than equal to 5. Sometime he'll give you a condition like that you need to plot the graph in between these values, or sometime he will just say the plot. That means you will have to pick up the values of x yourself. But here he has given you the values that you can pick up the values of x from 0 to 5. That means we are taking only the positive side. First again the thing, a is 1 in this equation, b is minus 5, c is 6. So a is 1 means it is positive. So the parabola will be opening upward. We calculate the word d, discriminant b square minus 4ac, which is 25 minus 24, it comes out to be 1. Again it is positive, that means roots are going to be real and distinct when the discriminant is greater than 1, greater than 0. If it is greater than 0, then it is going to be real and distinct. The roots are going to be real and distinct. Vertex will be minus b upon 2a minus d upon 4a. From that, the roots, the vertex came out to be 5 upon 2 and minus 1 upon 4. 5 upon 2 means 2.5, 1 upon 4 means 0.25. So now, and what will be the line of symmetry? X is equal to minus b upon 2a is the line of symmetry, that is 5 upon 2. So I drew the line of symmetry, x is equal to 5 upon 2, because I knew I had to plot from 0 to 5. So I wrote 1, 2, 3, 4, 5 and 2. 5 by 2 means 2.5. So I drew a line, vertical line at x is equal to 2.5, which will give me the line of symmetry of the parabola. Then we calculated the roots of the equation by substituting fx is equal to 0 or y is equal to 0, x square minus 5x plus 6 is equal to 0. We got the value of the roots to be 2 and 3. X came out to be 2 and 3. That means the roots will be 2, 0 and 3, 0, like you can see in this table. I made a table because he's wanting to plot, he wants you to take the values of x from 0 to 5. So I took x is equal to 0 and I substituted the value of x is equal to 0 in the equation. X square minus 5x plus 6, I got the value as 6, because if you see the equation is y is equal to x square minus 5x plus 6. If I put x is equal to 0, this will become 0, this will become 0, only 6 will remain. If I put x is equal to 1, 1 square is 1 minus 5 plus 6. 6 plus 1 is 7, 7 minus 5 is 2, so I've got 2. If I put it equal to 0, 2 2s are 4, 2 5s are 10, plus 6. 6 plus 4 is 10, 10 minus 10 is 0. If I put it equal to 3, 3 3s are 9, 3 5s are 15, plus 6. 9 plus 6, 15, 15 minus 15, 0. That is why corresponding to 3, already we had calculated the roots. These are the roots of the equation, 2, 0 and 3, 0. If I put x is equal to 4, 4 4s are 16, 4 5s are 20, plus 6. So 16 plus 6 is 22, 22 minus 20 is 2. If I put it equal to 5, so 25 minus 25 plus 6, this will cancel, you will get 6. Now I will plot all these points, 0, 6. 0, 6 will come here, then 1, 2 will come here, 2, 0 of course will be on x-axis, 3, 0 will be also on x-axis, because the roots means these points will be on the x-axis, 4, 2 will come here and 5, 6 will come here. If we connect all these points, join all these points, we get the shape of the parabola. Now you can see this line of symmetry. If this is the line of symmetry, these points are symmetrical about this line. These points are symmetrical about this line. These 2 points are symmetrical about this line. So that is how we get the parabola. As I told you that sometime he can give you the values of x, that plot the graph in between these points. Sometime he will say just plot the graph. Then you will take the values of x yourself. In the next question I have y is equal to minus x square plus 2x plus 3. Now we can clearly see here a is minus 1. If a is minus, that means a is less than 0, then we told you that parabola will be opening downward. Parabola will be opening downward. A is minus 1, B is 2, C is 3. We calculated the discriminant to be 16. It is greater than 0. So obviously the roots are going to be real and distinct, which I can see in this figure, minus 1, 0 and 3, 0. Vertex will be minus b upon 2a, comma, minus d upon 4a. That came out to be 1 and 4. 1 and 4. And the line of symmetry will be x is equal to 1. Line of symmetry is x is equal to 1. So it is 0. It is 1 here. I have drawn a line of symmetry here. And the vertex is 1, 4. So vertex has been plotted here. 1, 4. That is the highest point because it is going to move downward. And when I simplified this, when I factorized this, I got 2 values of x. One was x is equal to 3 and one was x is equal to minus 1. So my roots are going to be 3, 0, minus 1, 0, minus 1, 0 and 3, 0 are my roots. And I have to plot the graph between minus 3 and 5. Greater than x is greater than equal to minus 3 and less than equal to 5. So I calculated all the point, but I am not going to plot minus 3 upon 12 and minus 3 and minus 12 and 5 minus 12. It is going to go beyond my board, green board here. So what I am suggesting is that when you have the graph paper, you have the provision of taking the scale accordingly and you have graph to plot, so you can plot that line, but I am plotting between minus 2 and 4 only so that it fits onto this board. I calculated all the values and I plotted, and you can see all the points are symmetrical about the line of symmetry. Like it is 0, 3, it is 2, 3. This is symmetrical. The distance between this and this is 1, there is also 1. Then minus 1, 0, 3, 0. Here the distance is 2, here the distance is 2. Now here this point is minus 2, minus 5 and this is 4, 5. The distance will be the same. What is the distance here between these 2 points? 3 and 3 will be the distance on that side also. So all these points are symmetrical. That is why this line is called line of symmetry. Thank you. In this question, y is equal to x square minus 6x plus 9. He has not given any specific values where we have to plot in between. So we have to pick up the values ourselves. A is 1, B is minus 6, C is 9. So A being positive, the parabola is going to be opening upward. Now let us calculate the discriminant, which is b square minus 4ac, which is coming out to be 0. If the discriminant is 0, that means it is going to have equal root. The roots are going to be equal, and that means the graph will not be cutting the x-axis, but it will be touching the x-axis. Vertex are 3 and 0, minus b upon 2a, minus d upon 2a. From that we got the value of vertices as the vertex as 3 and 0. Line of symmetry will be x is equal to 3. So I have drawn a line at x is equal to 3, vertical line at x is equal to 3. When I solve this, factorize this rather, I got x is equal to 3, x is equal to 3. Two factors same, x minus 3 whole square. It is a square of x minus 3. x minus 3, x minus 3, x is equal to 3, x is equal to 3. That is why they'll be touching only x-axis at 3, 0. Then we calculated the value corresponding to 3, 4, 5, 2 and 1. Corresponding to 3 I've got 0, that means I've got the vertex. Corresponding to 4 I've got 1, x is equal to 4 I've got 1. Then corresponding x is equal to 5 I have got the value 4, y is equal to 4. Corresponding to x is equal to 2 I have got the value of y as 1. Corresponding to x is equal to 1 I have got the value of y as 4. You can see the symmetry clearly. This is the line of symmetry 2, 1, 4, 1. So these 2 points are symmetrical about this line. Then I have point 1, 4 and 5, 4. These 2 points are exactly symmetrical about this line. So you should understand why are we calling this line of symmetry. Okay, we have the question y is equal to x square plus 2x plus 2. I have to plot this quadratic function. I see that a is greater than 0, so obviously the parabola will be opening upward. I calculate the discriminant, which comes out to be minus 4. The discriminant comes out to be minus 4. That means the roots are going to be imaginary. That means the curve is going to be above x-axis. It will be above x-axis. It will not be cutting the x-axis. It is not cutting the x-axis because roots are imaginary, and whenever the discriminant is negative, we told you that the curve will be above x-axis or below x-axis depending. Here it is above x-axis because a is greater than 0, so it is opening upward, so that is why it is above x-axis. I calculated the vertex by the formula minus b upon 2a and minus d upon 4a, which comes out to be minus 1 and 1. So line of symmetry will be x is equal to minus 1, and then I plotted the points from minus 3 to 2 corresponding to minus 3, minus 2, minus 1, 0, 1, 2. I calculated the value of y as 5, 2, 1, 2, 5 and 10, and let us plot these values. First of all, I drew a vertical line x is equal to minus 1, which is the line of symmetry. We have to draw the line of symmetry because the vertex will lie on the line of symmetry because x-axis is there, x-coordinate is there. Now minus 1, 0 was the vertex. You can see minus 1, 1 is the vertex. So minus 1, 1 is the vertex. Then let us plot point minus 3, 5. We come to x-axis minus 3 side and go up 5, minus 2, 2, then minus 1, 1, then 0, 2 and 1, 5. I am not plotting 2, 10 because it will go much up. So you can see that I got a curve which is not cutting the x-axis, so it doesn't have actually real roots. It doesn't have real roots. That's what it has, imaginary roots, because the discriminant is negative. And this is the vertex, this is the line of symmetry. These 2 points are symmetrical about here, and these 2 points are symmetrical about this line also. Every time I am talking about the symmetrical point, because from one point you can plot another point symmetrically also. If you plot this side point, you can find by symmetry this side points also. So, or vice versa, you can do that. So this will be enough for you on plotting the quadratic functions. There are many questions in your book. You can pick out any question. Follow the same procedure what I have followed. The same procedure, you calculate A, B, C. From A, B, C, you can calculate the discriminant. You would know from A is greater than 0, then you will say parabola will be opening upward. If A is less than 0, then parabola will be opening downward. From discriminant, you will find out what about the roots. If discriminant is greater than 0, then roots are going to be real and distinct. If it is going to be 0, if discriminant is going to be 0, then the roots are going to be same, real but same, and that will be touching the x-axis as we did in the previous question. And if discriminant is negative, then roots are going to be imaginary, like in this particular question we are seeing here. We are seeing in this particular question that the curve is not cutting the x-axis. When the roots are going to be real, the curve will cut x-axis, whether it is upward parabola or downward parabola, but it will cut the x-axis. If roots are imaginary, then either parabola will lie upward of above x-axis, like in this case, or below x-axis. And when discriminant is 0, then the curve will be touching the x-axis, like in the previous case we had x minus 3 whole square as the roots x minus 3 into x minus 3. X was 3, so it was touching x-axis.